Hello, everyone. My name is Vince. You can call me Vinci, Venceslav Gaydarzhiev. Uh, Let me tell you a little bit about myself first, and then we can continue on discussing the dreaming and the exploration and a little bit of an invention that happened in the last few years for us at Alcatraz. So again, my name is Vince. I'm the founder of Alcatraz AI. Um, I I started Alcatraz with the dream to kind of change how people interact and authenticate in the physical environment, kind of like Face ID, but not on the phone, but in the real world. Um, Prior to this, I used to work at Apple. I led the team that created kind of Face ID and the integration of Face ID into the iPhone, including some iPhone and iPad development as well. And prior to this, I used to work at Nvidia on chipsets that used to be integrated in cars. Mostly, I used to work for Tesla, the first iteration of Model S, all the way back in 2011, 2012. What can I tell you about me? Originally, I'm from Russia, from Bulgaria. I was born 39 years ago, studied in the English language school in Russia, and I was never supposed to be connected to IT. My grandma used to play the violin. She was the first violin player in the Russia Philharmonic, all the way back in the 40s, 50s. She even called my mom Violina, because my mom was supposed to be a violinist player, and I was supposed to be a violinist player. I started studying, I started playing the violin, symphonies, concerts every year. But then when I was 12, my parents bought me a computer for my birthday. And I didn't have time anymore for violin. It was just my computer at home. Back in the days, in the mid to late 90s, we didn't have a lot of internet, a little bit of a dial-up. I was never about gaming. I was always dreaming to create something that people use and kind of feel useful, that it's in their daily life. So back in the days, we used to play with some software, how to make dial-up faster. We were connecting wires through Russia to have manual LAN networking, so things are faster in our town. And that's how I kind of started my dreaming, my exploration, my maybe a little bit of an invention in the computer business. My parents always wanted to send me away, not for good, just for a few years, just to learn some English, and then come back to Bulgaria. And the idea was I can go for a few years in high school, I can learn English. Initially, I went to Oxford High School. It didn't click for me that much. I came back to Bulgaria, and then I said, well, why don't I go to US, maybe for a year or two. I'm sure I'm going to like it. I've seen all the movies. They all look great. And I can come back. So my parents sent me. I almost came back the following week because there was a mix-up. Back then, there were not a lot of agencies that sent high schoolers from Bulgaria to US. I was sent. I was supposed to be in a host family, because you cannot just go when you're 16 somewhere else by yourself. But the host family ended up being this Native American a prison guard that had a lot of wolves at home. He believed in a lot of gods. I had to feed the wolves. I had to ride the bus in Florida for 2 hours in the morning, in the evening, while going back and coming back from school. In the desert, and I was like, wow, I actually like Bulgaria so much more. It doesn't seem like US is right like in the movies. I want to come back home and start on September 15th with my all my friends and continue high school. And just on my kind of like the last couple of days of me going back to Bulgaria, had a birthday. One of my classmates told my story to her parents. And her parents came to me and said, well, if you want, we can be your host family. We will adopt you. Just stay. And I did. Very different experience. Studying in, you can see here in the picture, Interlachen High School, which is the deep, jungly desert in Florida, but also connected to a lot of Christian activities. My family was a Baptist family that spent every Wednesday, every Sunday going to church, and I spent my weekends and going to Disney on church trips and so on. So this was great, and the following couple years I stayed. Then I stayed a little bit for school, then a little bit for post-undergrad research at school, just kind of studying to see how I can create actual stuff. I studied electrical engineering, microelectronics, how to create stuff with your hands that people can touch and actually love and enjoy and use. Eventually I graduated, and my first job out of school was for a company that really admired called Nvidia. Nvidia makes GPUs for PCs, for servers. Not many people know, but Nvidia also makes GPUs for cars. Back in the days, in 2010, 2011, this was just starting up. Nvidia was trying to make GPUs on embedded system on modules that went into tablets and phones. This thing failed a little bit because the GPUs were kind of big and expensive, too hot. But they were very, very good for cars. And since the technology was tried out and it was transitioning to be more for an automotive use, Nvidia said, well, this is before self-driving cars. This is before mapping all the roads in 3D. But what we can do is we can go and talk to all the vehicle companies. We can create all the partnerships. We can use our GPUs for their multimedia systems. And then eventually, when self-driving cars pick up, then we can use the GPUs for everywhere else in the car, including all the cameras. My first project at Nvidia was in the automotive division for Tesla. Tesla, even now, but especially back in the days, it was only situated within a few miles away from Nvidia in the Bay Area. Right next to San Francisco, there is Silicon Valley, San Jose, and the Tesla factory was in Fremont, and their main development office was in Palo Alto. So I spent the following couple of years basically camping out in the factory at Tesla, bringing up the multimedia technology, so the big screen, the small screen on the first Model S, before it actually came out for people to use. Initially, it didn't work at all. I mean, it couldn't run for more than 10 minutes at a time on any car. And eventually, with hundreds of people and a lot of testing, a lot of development, it actually kind of worked. Although the first test was when they came out in 2014, they still had some issues. They're fine now, and you can see what's going on with Tesla. So that was my first kind of project out of university. And it really taught me how to create something, again, that people love to use. It was kind of visible that Tesla is ahead of its time, and it will be different than any other car company because it was creating technology, not a vehicle with some technology in it, but technology inside just a vehicle wrapping. The main idea that Elon Musk had is not only going electric, but also creating an amazing experience for people to really enjoy when they're in the car. Maybe not enjoy the noise of the engine, not a lot of noise, but everything else around the car, acceleration, experience, and UI, UX, it's really different in a Tesla. So I was traveling around the Tesla factory, Nvidia, when Nvidia said, well, we're doing this with Tesla. We like what we see. We're going to go for all the other car manufacturers to see if they can adopt the same technology. And we started traveling. We went to Ferrari and BMW and Audi, Mercedes, Volvo, a lot of the companies out of Europe, some companies even in China, Nvidia was trying to get into. While traveling, actually I was on a plane or in between planes, someone from Apple called me. She was a recruiter, and the first thing she said when she called me on the phone is, hey, I'm calling from Apple, but our conversation should be kept between us. We have a position open. It's kind of rare that this thing opens up. Come to Apple. We cannot tell you anything more. Come to Apple. We want to show you what it is, and maybe you can think about if you want to join. So so that's how I went to Apple. Back then, the spaceship was not built yet. There were plans for the spaceship to be built. This was back in 2013. And I found out the team and the projects and the actual responsibility was exactly what I was dreaming of. It was actually more. It was about taking what Johnny Ives, which is the main designer back then at Apple, taking what Johnny Ives imagines and what Johnny Ives' team prototypes just with their hands with some plastics and material, not functional, just wrapping around a product, taking that and making it functional from early on stage all the way eventually to try out for this to be scaling to mass production. And you know, you hear about Apple, you see their products come out. What people don't know that's happening behind the scenes is usually when Apple develops one product like an iPhone or an iPad, there are 20 other iPads and iPhones being developed with the same at the same time with just a little bit different technologies, and then a few products that are not at all in the same category of what we've seen. And eventually Apple sees, okay, out of those 20 different prototypes of iPhones with different technologies, this technology is not ready yet for market. Maybe software is not ready, maybe yield is not ready, maybe the UI, UX experience is not ready. This is ready. This is not accurate enough. For example, sensors in the Apple Watch need to be very accurate for Apple to release a sensor that people can use and depend on. And that's what we were doing. We were just playing around with a lot of prototypes, not playing around, actually developing them at Apple first, then in the factories in China to find what sticks, to find what the best use cases are, the best experiences, the highest accuracy that we can get out of some technology, and then it can go into almost mass production. So those were my first few years at Apple. It was kind of like an engineering boot camp. You know, I would always remember the feeling of Sunday evening, because usually, you know, Sunday evening in California is Monday morning in China, and the factory wakes up after a Sunday, usually off time, and things start breaking in the factory, and we get a call Sunday night, our time, hey, line down, we cannot solve it, someone needs to come. And it's 10 p.m., my manager calls me, can you go on a plane in a couple hours, going to Hong Kong, then to Shanghai or Shenzhen, line is down, there are 20 other people that we're flying in to bring the line up. Because every day, every hour is key, especially for something like an iPhone that needs to be released on a very specific date, which means it needs to be ready to mass produce and all the new product line to be copied to 100 lines in China, and then they need to start manufacturing 5 million phones that are ready a week after the announcement of the phone, every day counts. Every day is hundreds of thousands of iPhones not being built. And it's really important, especially after announcement, Apple to have enough supply when there's a lot of demand. So yeah, you fly basically an hour and a half after you get the call. You go directly to the factory, you camp out for a couple of days, maybe sleep, maybe you don't sleep, you don't shower, eventually line is up again, everyone is happy, you go back to the hotel, you sleep, you don't even want to shower at this point. And you know, that's kind of the experience of a boot camp, creating a product on a very contained timeline, basically doing everything you can, no matter what the budget is, no matter how many people need to be involved, no matter if you need to call the government of China to unblock holidays and worker compensation and everything around the factory and in the region that may be happening in China. You do everything you can to make sure something like an iPhone has 10 million iPhones on the day of announcement, so they can actually ship. A few more things about Apple that you may be interested in. So Apple has, as many companies, Apple is developing vertical products like iPhones, iPads, Apple Watches, Apple AirPods, but also Apple and other companies are developing horizontal technologies that can be applied to many different products. So in this case here, I'm showing the Lightning connector. There was a reason why Apple developed the Lightning connector to have this secure handshake between their products and everything else, including power and accessories. And they usually develop this technology and they apply it per a good fit within those vertical products. One of those technologies that I was involved with, that I would say is one of the most complex horizontal technologies, is Face ID. So people know about Face ID a little bit. Maybe you have an iPhone, maybe you're using it. My grandfather is 95. He has an iPhone, he has Face ID, he doesn't know he has Face ID. I think he doesn't remember that we enrolled him. He's just swiping up, and it just works for him. That's the magic of Face ID. But people don't realize how complex something like Face ID is to really develop and deploy into maybe 500 million products, and almost all the time, and by almost I mean 99.99999% of the time, it should actually work. Apple was really ahead of their time on developing something like that, and even up to this date, nothing like that exists. Nothing like that exists even on Android phones. I'm sorry, Android fans, it's a little different there. Nothing like that even exists in the physical world. It took Apple many years, many acquisitions, probably hundreds of millions of dollars, maybe over $1 billion to create this. And you know, why it's so difficult? It's complex, but the thing is, it needs to be very accurate. It needs to work all the time, all lighting conditions, all kinds of people. It should not be spoofed. One of the biggest things about facial recognition is it needs to work all the time. It needs to let you in, but also it should not let someone else in, which is a real hard part, right? You can show a picture of someone on the other side, or now you have those deepfake videos. It needs to work all the time using 3D and infrared and RGB cameras and hybrid different neural nets to really make sure it's dependable. People can trust that technology. And then on top of it, it needs to be cheap. It needs to be small to be integrated in a phone. It needs to be not really hot. It needs to have all the check marks to be able to be deployed in 500 million phones and always work with a yield, from a manufacturing perspective of 99.99999. So that was Face ID, very technical product. Now it's been deployed into iPhones, into iPads, and we were really excited to kind of work on it even from early on when there were just schematics and layouts and some of the prototypes from the different acquisitions that Apple did to kind of get the technology in. This was an amazing experience, and what it taught me is how to create something that's so transparent that people kind of know about it, but they don't have to realize what's going on. It just works all the time, but somewhere on the side. This is the actual magic of technology. But then at the same time, even at Apple, even in all the factories, we were walking around and we're just looking at the physical environment and we're seeing badges, all the employees badge in, and guards, guards standing by the door asking people to badge in. Especially at companies like Apple, security is very important. You sign NDAs not only when you go in the company, but for every single project you work on, no matter if it's horizontal or vertical. Different rooms change security, access control rules. Maybe today the iPhone testing lab will be in lab 1, tomorrow is lab 2, because there is different technologies in there. People move around and tools move around, and the security guards, they don't know. They may be my friends knowing my name, maybe I've shown them pictures of my wife and my kids. They wouldn't really know if I'm tailgating someone after someone badged in, because they've seen my face go through this room 1,000 times in the last couple of months. So how do you solve for this? Well, a guard will kind of look at you. They will do manual facial recognition of your face and maybe the picture on the badge, comparing it. Okay, you look okay. You can go in. You may badge in, but then someone else can go behind you. And if the guard knows that person, they will let them in. You can solve this with turnstiles, those revolving gates, asking people to badge in all the time. But those turnstiles are not really fit for everywhere around on campus. Maybe in the lobbies, but that's it. So as we were developing Face ID, we said, well, what if we take facial authentication and apply it in the physical world, in the physical environment, in the built world for enterprise, for government, where there are high security applications, where maybe companies like Apple can afford 1,000 guards, but not all companies can afford 1,000 guards, and have the same kind of level of security as if you have a guard, actually better than a guard, for a fraction of the cost, using hardware, software, machine learning, computer vision. So that's how we were thinking about the early stages of Alcatraz. And then we decided, well, it's going to be easy. We did Face ID, piece of cake. We know how to do it. We just have to make a big iPhone and put it on the wall, and we call it a product for enterprise. Not really. Very, very different to develop first something from scratch, something that Apple doesn't develop, and you don't have the thousands and thousands of people as an infrastructure and all the vendors in the world actually fighting to work with you, because they know eventually they will have a contract for millions of something that they will sell to Apple. Very different to develop something that's not in your hand, that you can kind of control the environment of, especially in regards to facial recognition. When you have to deploy it somewhere and forget about it, but then especially in an enterprise environment, which is how we envisioned our product to be used, you have many people going at different angles, different velocities at the same time, different environments by themselves, single door, dual door, corridors, hallways, people going in and out, people not interacting with technology very well. Maybe one person will authenticate with their face, but the second person will have a mask, or maybe they'll be texting. You have no idea what the actual use cases and people's experiences will be, but you have to design for all of those people to make sure you're letting the right people in and you're blocking the not right people out from the facility. So that's what we designed. Very quickly, I'll show you a few videos here to get an idea. Later on in this afternoon, around 1:32, we'll have some of our team members doing deep dive into machine learning, computer vision, hardware, on our embedded product, and how we do the full stack on-prem and cloud development with a bunch of AI, and how we integrate into the infrastructure of those large corporations that we call our clients. I'm just going to go high level here. So that's our product. We call it the Rock, which is the nickname of Alcatraz as an island, as an ex-prison. Now it's kind of like a museum that, you go one time, you just don't want to go again. And the idea for the Rock is it does a lot of things by itself, and we call our category of access control autonomous access control. Just how you have in cars autonomous vehicles, and level 5 of autonomous vehicles is you may not be in the car even. You just maybe stay at home, the car drives around, maybe the car makes money for you as a taxi, and no one actually needs to watch the car. The same thing is the idea for the Rock. People should not really look at it. People should not be interacting with it. It will make decisions by itself based on access control and environments and people, and always have the correct people in and the incorrect people out. A few things on how we developed our technology. We had to make technology that's based on AI so people can enroll fast. Instead of you going to the badging office, you can just badge in a few times with your current badge, and we'll just learn who you are based on your face and badge. And at some point, we'll say, well, we've seen you enough. We kind of know who the owner is. The next time you show up, we'll just see your face, but we'll output your badge number as if you badged in. That's how we train our algorithms when we deploy the Rock on campus. And then after you badge in, now you can do single factor, dual factor authentication. Single factor is easy, you just go. You can see the experience in the video on the top right. You just go. By the time you touch the handle of the door, it's already unlocked. A lot of complex 3D, RGB, infrared facial recognition with anti-spoofing is happening. Tailgating check in the back to make sure no one is tailgating, and eventually we output the badge number to the access control system to open the door. But the magic is you just touch the handle and it's already unlocked. Dual factor is something like what we've seen in like online. When you log in into your bank account, you get a text message with a code, but in the physical world, you don't want to wait for a text message or an email. We do badge and face, and the face verifies that you're the owner of the badge, and that's how we let you in. And then tailgating is pretty easy to explain. You go, someone else may follow behind. If they don't belong, then we'll notify security. So what are the challenges really that we experienced doing this innovation? So it's not only about innovation of the product, it's an innovation on how you pitch, how you get investments. It's innovation about how you change the legacy mindset of the buyer, as the buyer is a little bit of an old school type of person, and innovation on how to get real traction fast as a startup. So you actually have the runway to show off revenue. So on the VC side here, it's really hard to get an investment for hardware. We do hardware as a service, but still, to create such a complex hardware, it's kind of like a robot without arms that we had to create. It just takes a lot of money, a lot of time, a lot of people involved. This is not just an app like a Snapchat where you can put it in the App Store and then you can debug if people are having issues and add features and have an MVP within days or weeks. It took us 4 years and $20 million to actually create something that's functional, that we can deploy legally in those companies and people can actually use and even start giving us feedback. VCs don't really invest in hardware because their mindset is, well, almost no hardware companies go to IPO. Almost no hardware companies have huge exits of tens of billions of dollars or even unicorn level status. So the risk is really high. Risk of how complex the product is and what can go wrong in manufacturing. Nowadays, supply chain issues through COVID. How long it takes to develop and test, especially when you go to large enterprise. You don't really get the feedback needed from your customers since they don't really want to talk about their issues in security and how you can fix those issues. It's just there are too many unknowns, and it's really hard to get investment. I probably heard more than 300, maybe more than 400 no's in my life, and it kind of plays a little bit of on your mindset that, is it good enough? Is the product good enough? Are you good enough? Is the company good enough? And I think the takeaway here is never give up. You just keep going, you learn, you perfect, you just get better and better. So investment in hardware is hard. That's the point here. Going into a large enterprise with a complex product, also very hard. I put down here some of the things that we had to work on, that we kind of call our product. It's not only about the hardware product that we have called the Rock, which is the embedded hardware with all the machine learning and computer vision algorithms. It's about its privacy of the templates and the security infrastructure of the corporations we deploy in. Our customer is a typical Fortune 1000 company, government agency with very high security standards. All the requirements on networking and IT infrastructure, a lot of enterprise level certifications that you have to show, like penetration testing, UL standards, ISO standards, SOC 2 standards to kind of prove that you cannot be hacked, that you know what you're doing with all the biometric data. We had to create this. And then going to those large corporations, we learned early on that they wouldn't allow cloud. We had to develop an on-prem virtual machine, kind of an infrastructure to run all the templates and create our own Alcatraz infrastructure in those companies. The legacy mindset is also a huge challenge for us. So think about who's the chief security officer at Google. The guy can be ex-FBI, ex-CIA cop, 30, 40, 50 years of experience. That guy's job, the main job, is to de-risk security, to de-risk how the employees feel day in and day out around campus, to de-risk maybe cybersecurity in the corporation, to de-risk all the vendors that are deploying software and hardware for security in a company like Google. And those guys don't really want to do anything to do with startups. Startups die, products fail, products are not really well tested. They're early on, especially complex products. So it was hard for us to convince large corporations to give us a try, because then we have to compete with the Nokia, the BlackBerry of the world. Yes, but those guys are well known with 50 years of experience. The security guards, the security guards and the decision makers, they know them. They've been in conferences with them. They've talked to their executive team. They know them in person. And us as Alcatraz, no one knows us. So, and it's kind of hard for us to talk about our real customers, because no one wants to be talked about. No one wants to show publicly that they have Alcatraz as a product within their environment. The last thing I want to mention that was a challenge for us is how to gain traction with the investment that we had. So it was very hard to get investment through many rounds of funding. Usually, this is a good graph, a good time versus revenue graph of a software as a service company. You have an idea, you get a little bit of an investment, it's called pre-seed, then you develop your MVP through pilots, you do some pilots, you get more investment, because now new investors, current investors will see, okay, there's a customer here, a customer there, they are willing to give you some money. If we give you more money, then you can hire more people and scale, and then you get a seed round, Series A round, larger investments to really go maybe into different markets, maybe create new products, and have a successful company on a contained timeline scaling. So that's a good, typical, I would say, SaaS traction representation of what should happen in a company with a potential product market fit. What's going on with hardware companies is it's a bumpy road. It takes a lot more money. You can see here the differences in the dollar signs in the pre-seed, seed, and Series A and Series B rounds. It takes more money, more time. It's a non-dependable sales cycle, especially when you go to large corporations with decision makers that take too long, with many customers inside the corporation, with many signatures that need to be done on the privacy, security, networking side, actual sales cycles that are so long that you really, as a company, as a startup, you don't know what to expect. And investors say, well, we need to give you 5x more money. There are so many unknowns with hardware, with manufacturing, with deployment, with maintenance and operational scalability of the company. It's too much risk. We've seen the other 1,000 companies that create hardware, no matter how magical it is, and 99% fail. It doesn't work for us. So that was our challenge, how to quickly run, and with a little investment and a little more investment, we show our investors there is a real market for this, and we can actually make it. We just have to get a little more money, and we need a little more time. So that's kind of my long story short. I think I want to finish with a few takeaways here. Always have an open mindset, no matter if you're creating your own company or you work for a company that's creating products. The product needs to give real value, and your customers need to love the product. Always talk to the customer and iterate, no matter how hard it is. For us, it was very hard initially to talk to anyone because no one wanted to share they have issues with physical security. It's okay to fail. I failed hundreds of times when listening to various nice, gentle no's by investors and other 100 times by customers. It always takes, here it says double, but actually triple the time, triple the money, triple the effort, triple the tears that you will have through a journey to create while dreaming and exploring. Thank you. Q&A now or later? Ivan. Ivan, Q&A now or later? Or Rado? Now? All right, Q&A. Any questions? What are the prospects for us to deploy our technology in private homes? Great prospects. As a company, we're always thinking about how to expand our market and go downstream into mid-sized businesses, small businesses, and eventually residential homes. It's just the technology needs to be more mature, I would say cheaper, be able to be created more at scale. It's actually easier to deploy facial recognition technology or facial authentication technology for homes, because then you don't have to enroll thousands of people and moving templates and enterprise environment with all the certifications. It would take some time to make it perfect for homes, but you can look out for those kind of things in a few years. Kind of like a Nest or a Ring doorbell, but with facial recognition. It will happen. Yes. Can you speak up, please? Can someone repeat that?
Sorry, can you hear me now?
Yeah.
About the bootcamp, if that saves that much money, why weren't you there pre-hand? I mean, if that happens so often, getting a call at 10 p.m., why weren't you there pre-hand so that can be avoided? And yeah.
You're talking about the bootcamp in China, and if it happens so often, whether, yeah, so there are many companies, including Apple, that have local engineers thousands of engineers in those different facilities, like Foxconn, Pegatron, the different factories, the different vendors, bringing up the technologies and eventually integrating the technologies in a new product line to eventually go to mass production. But there is development. As the technology is being developed in China, there is also development in Cupertino, or in the actual office where engineering is congregated in a company like Apple. And every once in a while, we learn about some bugs that only a few people did analysis on. They're experts in those fields. For example, a display technology or a touch technology. Think about PhD, ex-students that dedicated all their life on how to create the best possible touch technology to give you the best experience, for example, right? Though not all the time those people can be camping out all the time or move to China. They may be in California or Germany or somewhere else. And if you need that expert to solve some kind of an issue through testing, calibration, or bringing up software and hardware, you have to ship that engineer or team of engineers to China. And there's so many issues and so many experts around the world, especially in Cupertino. You just move people around all the time, every week, every day, to really make sure you expedite the line down of that different technology, because you cannot continue through the line when developing a product. If one of 1,000 things, one thing fails, you cannot continue on the next process of the testing or calibration.
One question regarding the long kind of prototype phase here.
Oh.
Sorry. How do you keep the team focused during this long prototype phase? Like, how do you know that you're really focused on the core things and you're not like building features that are not essential or will not improve the actual end customer value? Like, how do you basically know that you're doing the right thing? What is your feedback cycle in this kind of long prototype game?
Yeah, good question. So if talking about Apple, there is no customer feedback, right? Apple invents products with the vision of you make them and people will buy them. You delight the customer after they've seen the product or the product category that Apple is inventing. Many times now, Apple is not inventing a category. They're joining a category that's already there, but they create something that's more perfected, more well-rounded. At Alcatraz, it was really hard for us to get feedback by the customer because, again, the customer is a large corporation or government. They don't want to give us feedback. Most of our products, they're deployed on-premise, air-gapped. Alcatraz doesn't have access to the data. We can't even log in and see what's going on. Even if they tell us our product doesn't work, we have no idea what doesn't work. For them, it doesn't authenticate. So we have to fly someone, an engineer, in to debug the issue. Through this, we kind of get the feedback, okay, that's how we used it, that's what happened. Maybe it's an infrastructure, some kind of wiring issue, and we always try to iterate. Early on, when prototyping, we had some hardware issues, some machine learning, different corner cases of different lighting conditions. For example, I remember a large corporation that also has a huge presence in Bulgaria as a large office. They were doing a pilot with us, and they call us and they said, well, your product doesn't work. We've been testing it, but there is this guy that's trying to authenticate, and it doesn't work for that guy. Fortunately, this was cloud connected, so we could see what's going on. Well, the guy had a mask, sunglasses, a hoodie, and then kind of zipped up to here, and he was trying to run towards through the door with a light shining behind him. And we're facial recognition technology. We need some form of a face. It's like doing fingerprint scanning, but you have gloves. It's hard to authenticate. Fortunately, we were actually able to solve a lot of those challenges with just data and training of new neural nets to kind of compensate for the different lighting conditions, different skin tones, maybe not needing the full face, but a portion of the face, which affects accuracy, but the experience is also important depending on the deployment and how many people enrolled. And then just go. You deploy the new software to the customer, and you get their feedback. And then if it's great, then you deploy to everyone else. And that's how you kind of solve for all the different corner cases of whatever you didn't test in the lab, right? But it's one out of many, but not enough feedback cycles we have, just because our customer is not a typical customer. They're very limited in what they want to share. Thank you so much.